Okay, and while Julian's setting up, I'll just briefly introduce him. Julian is a research software engineer for MIT's Julia lab. This is Alan Elliman's lab there. He's the author of many critical practices within Julia ecosystem, among them AMD GPU, maybe most famously Dagger, um, and he's really interested in HPC. So if you haven't seen him before at this conference, I think he has a Dagger Burst with a Feather, discussions on AMD GPU, and also he's on the Julia GPU panel.
Yep.
And so today, Julian's going to be talking about cancellation, aka the big red button. If you're watching Nathan's talk, you may be wondering how do you abort compression or decompression when things
Check.
go awry, and this could be something that maybe Julian has some insight on. So Julian, thank you, and please go ahead.
Thank you for the introduction. All right, so today I'm talking about cancellation, what you might often see as a big red button in movies. So I know this is the IO mini, so cancellation has a lot of relations to IO. I'm going to dig into cancellation and then we'll kind of see towards the end how this all can tie together. So why do we need good cancellation? So I'm sure there's plenty of people here who've heard about the Therac 25 radiation machine. If you haven't heard of it, it's a great example of when cancellation goes wrong. Basically, you try to cancel, radiation while it's being given to a patient, and suddenly the machine's like, oops, I'm going to crank it up 100 times and subsequently either kill or permanently maim the patient. This, obviously this device was, recalled by the manufacturer or whatever, but it was a big reminder like, be careful with your code, be careful with, what the stop radiation button means, and make sure it actually does what it says. Um, so where do we see cancellation in the wild aside from the wonderful Therac 25 machine? So it really is everywhere. So we all know Ctrl-C. That one's straightforward. If you use Windows, I'm sorry for you. It's Control-Alt-Delete for getting to the task manager and all that, and then clicking kill program or whatever. But other examples in life are brakes. Canceling your forward velocity so you don't run through a guardrail. Fire extinguishers, if the fire is the computation, fire extinguisher is how you say stop, please. Pepper spray, I don't need to explain that one. There are many examples in life, but obviously, this is a computer science conference, so we'll get more towards that. So the history of cancellation is reasonably long. I mean, we've wanted to stop long-running computations for as long as we've been doing computations and as long as we've been writing bad code. So back 60s to 70s, you had a button to basically shut off machines. The power button is always, your last resort, but that's not very graceful. Probably took forever to start back up the machines back then. In the 70s to 80s, Unix formalized SIGINT, which is what Control-C actually triggers. When you hit Control-C, it just sends a SIGINT signal to your process, as well as SIGTERM and SIGKILL. SIGINT and SIGTERM are kind of graceful-ish cancellation. It's not really, but we'll get to that. And then SIGKILL just says, nuke this process, go away. And that's what we would call forceful cancellation. In around the 80s to 90s, we started having multiple cores in our processors. This complicates things because, how do you cancel not just work on one single thread, but multiple threads and have things all kind of like work cleanly so like your data isn't corrupted and weird things don't happen? And in the modern era, we've started to see a proliferation of more cancellation tools. .NET has its famous cancellation token. Go has their channels, which are, closable and whatever. I didn't really look into how they do cancellation. Python Trio, which is kind of similar to cancellation tokens. They have some similarities. It's a very structured cancellation mechanism. JavaScript has its own thing, and Erlang is like has the phrase "let it die" as their motto because cancellation is built throughout the language, very nicely integrated. So, just to reiterate what kinds of cancellation actually exist. So there's forceful cancellation. Sig kill is one of those, as I've mentioned. A power switch is another. Hammer, flamethrower, various other objects can be used to smash your computer into pieces, and that will stop the computation. Might start a fire in the process, but at least you stop the computation. In Julia, we have Ctrl-C. Some people might call that graceful. I would actually call that forceful. We will get to that. Graceful cancellation, sig int, sig term. Okay, technically, I put Control-C in both. It's kind of both. Hibernation is kind of a way to cancel code. If you like close your laptop and it hibernates or goes to sleep, your computation is paused. Your laptop's not doing stuff. Technically works. And Julia, what do we have? I'm not sure. Kinda sig int. And then structured cancellation. There are cancellation tokens. Python has Trio and its nurseries. You can look into that if you're interested in your own time. And a few other things we're going to discuss. So why do I care? So I care because I develop currently Dagger.jl, a task runtime, parallel, whatever library. Many of you probably saw my talk yesterday. And AMD GPU.jl, which is Julia interface to AMD GPUs, as the name suggests. With both of these, it's very common that you run some code and you're sitting there waiting and you're like, this should be done. Why not? And so for me or for the average user, if I just hit Control-C while something's running, most of the time it does not work. It does not do the right thing. And my runtime is just broken in unexplainable ways, and I'm like, screw it. I'm gonna just close Julia. What I really want is I hit Control-C, and Dagger and AMD GPU and other libraries get the chance to gracefully stop, clean themselves up, do what they want. They can do things like print, a little debugging summary of what was happening in the runtime. You could tell the GPU, please nicely stop these kernels from running. I get the REPL back, and my libraries still work fine. That's the hope. That was not the button I intended to press. Okay, there we go. So what does cancellation in Julia look like right now? So let's take a look at Control-C, also sometimes known as interrupt exception, being that that's the exception that it throws. So it's what a lot of people rely on. I think most people in this room use Control-C as kind of their first line of defense. What does it actually do? So it first finds some task, any task. It's kind of playing roulette. You just kind of which task is kind of doing some stuff. We throw an interrupt exception into it. We literally just kind of shove an exception in there. And then at certain points during the task's execution, it will do a yield or exception handling, and it will basically see, oh, wait, there's an exception. I now need to throw this. Jameson will probably have some objections to some of the stuff on the screen because I know this is not all fully accurate. I don't recall all the specific details, but it's an approximation. So is this a good idea? I would argue probably not. I think many people who have worked on Control-C also would argue it's not great. And as apparently was mentioned during the keynote today, it's kind of just completely broken in 1.13. So one of the big problems is that you're kind of just A, randomly picking a task, and B, just forcing an exception into it. And that task is maybe not prepared for that. And often you're just picking the wrong task. Like in Dagger, frequently it will pick the scheduler's background task, which is not doing anything. It's just sitting there waiting for Dagger tasks to complete. And if you kill that thing, well, then all these tasks blow up in all different ways, and Dagger usually recovers, but it's not great. Not every library is going to do well there. And often, of course, I'm sure plenty of you have seen this with certain types of code. You'll get a segfault or an abort, and that just sucks because now you can't even debug why your code was stuck in the first place because there goes your session. So can we actually control what Control-C does? No, not right now. You can try to catch interrupt exception. People try to do that, and it makes me cry inside, but also, what are they going to do? That's basically all you can try to do. So we'll take a look into some solutions in a bit. But let's just take a look at when Control-C does and does not work. So in the first example, we have sleep. So sleep is pretty nice. You can often hit Control-C while you're in the middle of sleep, and it will actually stop. It'll throw an interrupt exception, and then, print's done, and it didn't run for the full 10 seconds like it expected to run, and that's good. That's what we want, okay? We were able to turn a 10-second really long sleep into just 2 seconds of waiting. That's good. We can get on with our lives. Wait, which is actually the primitive that sleep calls internally, and also a lot of Julia internals and various libraries end up calling wait to basically put their task to sleep until something happens. That one also is cleanly interruptible for the same reason that sleep is interruptible. And additionally, something that I'm sure many people have used, reentrant locks, or various other kinds of locks. If you're waiting to try to lock a lock and some other task is holding it, and you're like, you know what, I give up. That task is stuck. It's doing something. This lock will never be unlocked. I can hit Control-C and we'll just stop trying to take the lock. And that's great because then we can go do whatever we need to do to fix things up. When Control-C does not work. So if, for example, you call into C, you do a C call, you call into Fortran, you call into whatever library, you can't just assume that you can hit Control-C. You may not know you're in a C call, and that, again, is something that we need to figure out generally, but, if you're in a C call, there are no guarantees what's going to happen when you hit Control-C. Additionally, and, you can see at the bottom with System Sleep 10, I can hit Control-C in the middle of it. It's still going to go the full 10 seconds. And then, oh, look, a Control-C. Oh, I should stop. Too late. It's already been 10 seconds. I'm bored. Another example is infinite loops. These do not do any kind of yielding, waiting, whatever. They just spin in a circle. They don't ever actually check if there's been like an interrupt exception or Control-C or something like that. They'll just keep running. Yeah, you can hit Control-C almost all you want, and it will just keep running. You can hit Control-C really fast a lot of times to force it to interrupt. That's a whole other thing that is dangerous, and, if you do that, expect Julia to just be dead in the water. Sad panda. So, a potential solution to Control-C. So, I put together a PR over 2 years ago, and I still have not gotten it merged. That is my fault. That's nobody else's fault. Which basically tries to fix this issue of Control-C's behavior by doing a few things. So what it basically lets you do is say, I'm going to register a handler with Julia's runtime, and when Control-C is hit, Julia's runtime is going to call that handler. And there can be multiple handlers. Dagger can register a handler, AMD GPU, all of the libraries, whoever wants to have cancelable code can register a handler, and that will get cleanly called at a safe point, not a safe point specifically, but a safe time to call that thing. And it doesn't randomly pick a task anymore. It only calls those handlers. If any handler is registered, it'll call those handlers. It'll even helpfully pop up a menu, so you don't have to, trigger all the handlers. You can say, no, just Dagger is being a pain in the ass. I'm going to cancel Dagger. Understandable. And additionally, it provides a mechanism in base, so base and the standard libraries can actually use that, which is great. We want everybody, including Julia itself, to be able to use this mechanism. It does have problems, though. So it only triggers sometimes, like how I said Control-C, that interrupt exception only gets seen at certain points. So too are these interrupts noticed. When Control-C is hit, we don't actually trigger those handlers until it's a safe time to do so, and that only happens at certain points, yields, exception handling, etc. If you're deep in the middle of, heavy computational code, it's not going to trigger anything. So that is unfortunate. And so it doesn't do anything about non-yielding infinite loops, C calls, etc. And it's also, if you look at the implementation, I'm so sorry, it is complicated. I hardly understand how it works. Maybe I will recall it if I go back through the PR and maybe if I have Jameson by my side. So one point that I just have to kind of reiterate is like not a lot of code is actually just like by default interruptible or cancelable. If you don't call one of those magic yield, wait, sleep, whatever functions, there's not an automatic point to really be able to cancel your code. C calls are obviously another example of this, but you can also imagine if you have some code that's going along, updating data structures, doing whatever, and you were to just arbitrarily say, nah, stop and cancel, well, what happens to those data structures? They might be completely corrupted to the point where the next time you try to use them just causes a seg fault or some stuff blows up. We don't expect our code to just like the compiler does not generate code expecting that at arbitrary points it might just get interrupted. And that is a big issue needing to be discussed among the compiler developers. But still, this will be a problem regardless. So it's not great. Arbitrary code can't just be stopped as much as we wish we could, unless you're using a power switch or a hammer or flamethrower. But anyway, we'll forget those. So another alternative to Ctrl-C is cancellation tokens, or in this case, cancellation tokens.jl. This is basically the .NET approach done in Julia. Just doing a quick time check. Okay. And so it's basically an easily programmable and controllable way to do cancellation. So you create a cancellation token. It's actually cancellation token source. I mistyped that. And what you can basically do at any point, you can just call cancel on the token. And then at any time in code that actually wants to be cancelable, you can just check the token and be like, has this been canceled? If it has, you can clean up, you can throw an exception, you can do whatever you want to gracefully clean up and cancel your computation. Dagger can, have these tokens and clean itself up however it wants to. It's easy to integrate, it's extremely lightweight, but it is not integrated with base or the standard libraries, and so you can't actually threads.add_threads could not use cancellation tokens unless there was some way to add a dispatch on cancellation tokens as a package extension. I don't know. So a lot of things won't be able to use it. It's also not yet thread safe, but I'm planning when I get some time to fix that. Let's just take a quick look at how it's used. So again, you load cancellation tokens, create a token, you spawn your computation. For now, we're just going to spawn it on the same thread because again, it's not thread safe. Say we're just doing some really big, heavy matrix inverse, whatever things. I don't really care. But periodically, we're checking this token and saying, has cancellation been requested? If so, let's bail out. And our A vector should be clean and, isn't corrupted in any way. It's just a little bit shorter than it would be if the whole computation finished. And you just call cancel to cancel it. As another option, and this is probably Jameson's preference, and sorry for all the call outs, Jameson, but you helped me so much with all of this stuff. So what I've heard from Jameson is that resource-based cleanup is really the way to go. So this is basically the is open close sort of mechanism. So the idea is that your cancellation is tied to a resource. So say you're using some kind of resource, whatever it is, and if you want to cancel computations that are using that resource, you just close the resource. You just call close on it. The resource isn't supposed to be usable anymore, and anything else trying to use it should just stop. Whether by checking is open on the resource or just getting an error when you try to use it. For example, with channels, if you close them, you take all of the elements up to that close point. The next time you try to take, you'll just get an error. You'll get an invalid state exception, I believe. And that can work great. We use that in Dagger all the time. It works pretty reliably. There's interfaces all throughout base and the standard libraries for this. But what if you just want to interrupt generic code? There's not always a resource to cancel. And so it doesn't always provide what you need. However, you could do something like this. So let me back up. What if we want to tie together the last two ideas, cancellation tokens and close? This is something I just completely thought up last minute while putting these slides together, but what you can do is you can have both. You can have support for is open close, resource based cleanup, and cancellation tokens if you add a cancellation token to your resource and use that as the mechanism through which you check if the resource is open and close it. So here, basically the same example as before, except it's now checking whether the token has been triggered or not through the resource, and you can just call close R, and that will trigger the token, and then et cetera, et cetera. You all know how that works. I think that's straightforward. So which libraries can benefit from this? Um, so as mentioned, Dagger, libraries like Dagger, qnumeric.jl, awesome talk about that. You should all watch that on YouTube. The GPU packages, web libraries, so HTTP, Oxygen, anything doing those long-running network requests, numerical code, diffeq, linear solve. These things are long, long computations over many time steps. It would be great if I could stop it maybe, a few seconds in and be like, that's good enough. Et cetera, et cetera. Base standard libraries, of course, threads.add threads. We want to be able to cancel it if it runs for a long time. Distributed next, James, we need to talk more about that. And really applications of all kinds. And so my thought on the best path forward for the future is merging my PR. Obviously, once we get it all fixed up and I, figure out how it works again, get it all cleaned up, get test passing, whatever. And then, if a resource exists that we can work with, implement is open and close. That's what you should do. Consider also supporting a cancellation token that can really help people out who are working with code that doesn't have a chance to call close, but still wants to be able to do basically that closing of the resource. If a resource does not exist, take a cancellation token source as an argument. Depend on cancellation tokens. It's pretty lightweight. And just check it periodically and exit if cancellation is requested. Do whatever cleanup you want. We talked about this. When all of this is said and done, well, I guess things will be much better. We'll be able to interrupt and cancel arbitrary code. We would have to add cancellation tokens to all packages that do anything long running, presumably. We need to discuss this and see if this is the best way forward. Thank you all for listening.
Okay, thank you, Julian. Are there any questions?
In that last slide, you referred to adding cancellation tokens to everything. Are you talking about cancellation tokens.jl, the package, or having cancellation tokens in base itself?
Yeah, that's a great question. That I forgot to mention that. Thank you for bringing that up. I do personally feel like cancellation tokens should be in the language so that base and standard libraries can also use it. And so this is something you kind of want to agree upon throughout your entire ecosystem. Otherwise, you have 5 different ways to cancel code, and you thus need to try all 5 when you're trying to hit like Ctrl-C or something. So yeah, I feel like really this should end up in the language, but we can trial it through packages and see what happens. And then like what we did with scoped values, we had the scope values package and then it moved into base. So I think that approach could work.
Any other questions? I have one. I think you mostly talked about cancellation in terms of the user wanting to cancel the task, but I'm also thinking about situations like timeouts. I'm waiting on some input, and I'm done waiting. Need to do something else now. Should that kind of timeout use the same kind of cancellation, or should we distinguish those things?
Yeah, so the way that it's implemented in libraries like Trio, which do structured cancellation, I believe is that they essentially take in a token and then on timeout they're triggering that token. Either way, I'm probably misremembering this, but I would say that it should still all go through these cancellation tokens because if there's a timeout and you cancel one piece of code, you may want to cancel some other code that's running together with that. If, for example, the thing that times out also has a bunch of other tasks that are running together with it and doing some processing. And so I would say that, and I mean, the nice thing is you can make as many tokens as you want. You can chain them together. You can create whatever kind of structure you want. That's why it's called structured cancellation. So you can build it to really suit, whatever the behavior should be.
So I was doing a little research about this, about what's out there, and uh, one interesting approach, which I think Swift takes, is that their tasks, or I guess they call them actors, they're a task-like construct. All tasks have a cancellation token embedded in them. I don't know if they call it, but basically is and you can do a query about like, oh, am I canceled or something? And what do you think about like putting that into the task? You kind of lose a little bit of the structure of it because it now every task has one instead of the user like making a little tree of cancelable things.
Yeah, that's an interesting idea. I am not sure how that would work out because one issue is that how do you you could just say Control-C means send cancellation signals to all tasks, or there's just one token shared by all of these tasks. That could also work. But you do potentially want the ability to do targeted cancellation because Control-C is just the mechanism to say, I want to stop something, but it doesn't say what. And I think it would be a big improvement to also be able to communicate the what, because sometimes I know it's dagger. I just need to cancel dagger. That's fine. But I think that's something worth thinking about. Good question.
Any other questions?
What would you say are the next steps for getting this into production? Like one of the things you mentioned was adding or making cancellation tokens.jl thread safe. What else could people do?
I so thread safety of cancellation tokens, and then I honestly think we're at the point where we should start wiring up cancellation tokens.jl into a lot of libraries, regardless of getting the Control-C handling done, because at the very least, once you do that, you can still call cancel and cancel stuff. You don't need Control-C for that. Control-C is the convenient mechanism. It's what most people instinctively reach for, but we can teach people in the meantime call cancel, make sure to, run your code in a task so you get your REPL back and you can call cancel. We can implement support in GUIs to have a button for cancel. We can make a lot of progress with cancellation tokens in parallel to getting Control-C fixed, improved, whatever you want to call it. So I think there's really two paths that we should start down as soon as possible.
I noticed you didn't mention control backslash, and from someone that doesn't know anything about cancellation, how that plays out with everything you talked about.
Control backslash is usually sig term, and sig term just often happens to be better at telling Julia to GTFO. However, it is kind of forceful. It's sig term, terminate. So you're telling Julia to shut down gracefully, whereas sig in or Control-C is saying just stop your computations, but give me back control. So kind of two different purposes. We should talk about that more as we develop this because they both are still cancellation and they both need to be considered, but I'm not sure what that would look like.
So would that imply that we need different kinds of cancellation tokens, like a please stop or versus stop right now?
Well, I guess if you have the please stop for the moment for Control-C, you can also just use that for sig term, and at least it'll stop the computations. And then when Julia closes and cleans up, things like GC finalizers and at exit handlers will do the final cleanup of getting everything shut down nicely. But I'm not sure if that will cover all cases and if that'll cause problems. So I really haven't thought through that too much.
I guess what I was thinking about is like one Control-C versus the user spamming Control-C because they usually need to stop something.
Yeah. Yeah, there could be a force like a less graceful form of cancellation, which Dagger does implement. We have 2 different kinds, and you can trigger either one. And one is like drop the nuke on these tasks and really try to get them to stop running. But yeah, that's a good point. Worth thinking about more.
Thank you.
Thank you.